Okay, so this is chapter 15 in the big book. It's a different chapter in some of the other books. Connecting and setting up a network. Connecting to a network. And one of the things that I have been told that they do ask is for you to do some connections on your smartphone so we can use Keith's smartphone to teach everybody how to set up email on it. But that's one of the things that they do ask you in the simulation to do. And walking past, I saw this. They had this great big huge motherboard that you had to label. So expect those kinds of things on it. Okay, so the objectives, TCP/IP protocols, the things that are used on the internet and standards Windows uses for networking. The protocols, they expect you to know some of them, the major protocols, not all of the minor ones. Learn how to connect a computer to a network. You've probably done that multiple times. Connect to a wireless network, you've probably done that multiple times. But those are the kinds of things that you should know. Learn how to configure and secure a multi-function router on a local network. Probably, I think, a little bit in depth for this one, but I do have a wireless router, that multi-function router that you can do some configurations with in a packet tracer file. That is one of your labs for tonight. TCP client-server applications, 2 computers, and one of the things that we're talking about earlier, communicating between them, one of the protocols that we're going to use is DNS. DNS is the one that takes a name, www.yahoo.com, and makes it an IP address. When that happens, that IP address gets stored in cache on your computer. So that if any of the IP addresses change, you now have to make that cache go away. And that's using just a flush ipconfig/flush DNS does that. So 2 computers and 2 applications are involved in this. Occur at 3 levels: the hardware, the operating system, and the application. Dependent on one computer addressing the other, we have to be able to get from point A to point B. And the addressing that it's going to use is going to be IP addresses. And you can find out what the IP address of the other system is if you ping it by name, and you will get a response back. That then gets put into the DNS cache and is stored there until you either flush it or restart the computer. The reason that becomes hazardous if you start changing IP addresses on machines, or if you move a machine from one location to the other, the name may be associated with the now incorrect IP address. And if you use the names, then they won't resolve correctly, and you just have to flush it. When we move machines around in Active Directory uses DNS to find stuff, and then you move it from one room to the other. It's listed in the DNS server with the wrong address, or maybe 2 addresses, and sometimes it'll work, sometimes it won't. You've got to flush all that, get all those old records out so that you can start them fresh. 2 devices communicate. They must use the same protocols. Almost all networks, all networks use TCP/IP. TCP is what's called the transport protocol, and IP is the routing protocol. IP is the one that actually finds the resources. TCP assists it with ports. Ports are going to be associated with services. There's a chart out here on the wall that has the major ports, and one of my favorites has always been 666, which everybody is scared of. 666 is Doom. Doom runs, if you got port 666, the game Doom runs at 666. The web servers, you go to www.yahoo.com or Google or wherever else, the service that it runs, the port that it runs is port 80. The service is a web server. A secure web server is on port 443. Email, which you'll probably have to configure when you take this test, runs on 3 ports depending on what they are. The 25 for SMTP, Simple Mail Transport Protocol. You send on port 25, you receive on port 110. 2 different functionalities there. And then there's another one, 143, which allows you to read your emails on the server. Yes?
What's all these numbers mean?
Those are the port numbers that the connection makes, the TCP port numbers that represent services. When you go to the web, you type HTTP, www, something another, right? HTTP is the Hypertext Transfer Protocol, right? You agree with that? When you get to the other end, to the web server is operating on, it's sending stuff out on TCP port 80. When we actually want to get something, we have to have the IP address and the port number, a location, and the service that we want. So all these numbers are TCP port numbers. They represent services, the Doom game, the web server, the email server, FTP, Telnet, all sorts of different ones that are available. There are a total of 65,565 ports. You don't have to know them all. 1024, below 1024, 1023 and below are the ones that are supposed to be the well-known ports that actually have the ones that have services that are popular, well-known, yeah, and not all the ports are used. But they do expect you to know some of the major ones, like 80, 25, 110, 143, maybe 23 Telnet, FTP 21. There are charts, and there's a chart out there, and I think there's one in your resources that, and if not, I'll put that chart in there that has those. Actually, if you look at the objectives for A+, it's got a list of the ones that they would expect you to know. So you can use their own objectives to figure out which ones, which ports.
Exam, they put their own test out. They put like their own practice tests.
Yeah, there is a practice test from CompTIA.
And they got their own book, I'm guessing too. Right?
They do, but it's the same content. We use a Network Plus book by Tamara Dean that is Course Technologies. There is another book by Tamara Dean that has the CompTIA name on it, and page for page, chapter for chapter, it's the same book. They just put a different cover on it. So yes, they do. The book that you have covers all of the objectives for A+. It's one of those endorsed things. Data is broken into segments, and each segment is put into a packet. These are all terms that, when you do Network Plus, will make a whole lot more sense. What it's saying is you can't send everything at once, and it's going to break it up into smaller parts to send it. TCP is then going to put a number on each one of those so that when it gets to the other end, it can put it back together and check to be sure that it got everything, that it got all of the numbers. So TCP does that for us. The network layers, the hardware layer, root level, communication, wireless or network cables, phone lines, so we're talking kind of the basic stuff. Includes a network adapter and MAC address. MAC is media access control. A MAC address is what's called a burned-in address. Each NIC and each thing that gets an IP address, at the manufacturer has an address, a 48-bit address burned into it. When you went to, how many of you have Cox cable for internet? When you hooked up your cable modem, one of the things that you had to read to them was a string of numbers, hexadecimal numbers. You didn't realize it at the time. That was the MAC address of your cable modem so that you could get an IP address on it. They put it in a table and said it's okay to give you an IP address. But the MAC address, burned-in address, is the physical, it's called the physical address of the machine, or the router, or the wireless access point, or the whatever. The hardware address, physical address. And this is where these ports come in. Little picture, not a great picture, I guess, but a little picture. Web browser, Internet Explorer, Chrome, Firefox, whatever we go to, www, and they're going to course.com/index.html. It goes across here, the port address that it's going to go to with HTTP here, it's going to go to the IP address where the server is. And then it's going to go directly to the HTTP service, which runs on TCP port 80. Two different functions here. The port numbers represent something that you can get, a web page. We work from the way up, the MAC address, network card, MAC address, operating system, TCP, IP addresses, and then up here the port address, which would be an application. But the numbers represent something, a service.
When you open up the browser.
When you open up the browser, it goes to the operating system. Well, we open up the browser. This works its way down. We open up the browser, it goes to the operating system. From the operating system, we get the TCP IP address. We know what the IP address is, and then it goes through the NIC, kinda through the internet. MAC addresses eventually. Ethernet doesn't go across the internet. That's what's kind of deceiving about some of these pictures. Ethernet only goes 100 meters. So can you imagine going across the internet with having to put a repeater, amplifier, repeater every 100 meters? We use different protocols to go different distances. But we'll pretend that they're right here. We go across the internet, we get to the NIC at the other end, and it works its way up to the web server. The web server represents something. We don't get to the web page, get the whatever you're looking for there, the game or whatever else. And then it sends an answer back from port 80 back to your web browser, whatever it started on. And it happens really quick, yeah. When you think about the distances that this stuff is going, it's almost instantaneous. If you go to London, Hong Kong, New York, Chicago, Los Angeles, whatever, it's a nearly instantaneous response. So it is really, really fast. The operating system manages communication between itself and the other computer using TCP/IP, uses IP addressing. What, at this point, you're going to need to know how to do is to put an IP address on the computer. Once you're given the IP address, how to configure it. So IP is the thing that's used to go across the internet. And what this is showing here, the communications within the network, within this room, for instance, we're going to use the MAC address. The MAC address, every computer has a different MAC address. So that's unique. You can change the IP address.
The MAC address comes from the manufacturer.
Comes from the manufacturer. You can change the IP address, and that's where we get the associate the IP address to the MAC address, because eventually you're going to have to get to the individual computer to get what you want or to give what you want. So we have two of those, the physical address and then the IP address called a logical address because it can change. The operating system layer IP address, 32 or 128-bit, 32-bit IPv4, IP version 4, which has been around for a lot of years, and they've been saying for a lot of years that we're going to switch to the 128-bit IP version 6 imminently, and it's been imminent for, I don't know, 5, 6, 7, 8, 10 years. Eventually, we're going to have to. All of the version 4 addresses have been issued. There are no new addresses. What, that there are no new addresses? Because they gave them all out?
Hold on, so 32 numbers.
32 bits, not 32 numbers, 32 bits.
Right, that can include numbers and letters?
Nope, just ones and zeros.
Oh.
A bit, 1 or 0.
Oh, that's why they run all
32-bit, there's several million of them, but yeah. IPv6 has 128 bits, so whatever, the 2 to the 32nd, I don't know what that number is, that's how many addresses you have. You really don't use them all. 28-bit, 2 to the 128th, which is there's been lots of analogies. One, there's more IP addresses than there are grains of sand in the world, and there's, everybody can have like 10,000 of them or something like that, including China. Like more than 10,000, but there are a lot of addresses. When they started the 32-bit, they didn't think they were going to run out. They've done other things that will be discussed in, and I'm putting a lot of this on Network Plus because of networking course, because you'll get that stuff in the networking course. How to configure. These guys over here have had it. You get all that. You'll get sick of all that in the networking course, especially when you start subnetting, right? The magic word, which we're just going to say the word and we're going to move on.
So you type in your IP address, it's a 32.
Yeah, the IP address, we use numbers. We use decimal numbers. The computer reads binary numbers because that's all it understands is ones and zeros. It translates it to binary ones and zeros. We're going to have an example here in just a second. Use to find computers on the networks and subnetworks, including the internet. The application layer communicates with other server applications. The port number uniquely identifies a computer application. These computer applications aren't Microsoft Office or Open Office or Solitaire or things like that. These applications are things like a web server, a file transfer server, a print server. So they have to have a port. A socket is another term. Is an IP address plus a port. And that's where you actually get something useful, is putting those two together. The email example, 36.60.30.5 is the IP address, :25. 25 is the port address. The reason you don't have to put that port address in your web browser, that's XMTP, that's a mail server.
So what is
25 is the mail server. 5 is just the end of that's just the end of the address, because each of these is an 8-bit number, 8-bit binary number. So 32 total bits, 8, 16, 24, 32, 32-bit binary. And again, they've got an example here in a couple of minutes. A web server, 136.60.30.5 with port 80, :80.
80 you use
80 you use to go get. It's kind of like a phone, which people just use the text. But if you're actually calling somebody on the phone, what phone number do you have to call to get Guy?
25.
What phone number do you have to call to get Guy? So you don't know his number, but you have to call his phone number, right?
Yeah.
If I wanted to talk to you, I'd have to call your phone number, right? What phone can I call from? Any phone. Port numbers are the same thing. If I want to get to a web server, I call port 80. If I want to send email, I call port 25. If I want to get my email, I call port 110. Does that make any kind of sense? They represent something, and it really is like a phone. The sending machine also has a port number, but we don't really care what it is. It's a random port number because it doesn't represent anything in particular. MAC address is embedded at the factory. Said that already. IP addresses are signed manually or by software. Static is when we type it in. We also have a service that will give them to you automatically, because when you start the computers up here, they get the addresses automatically from a thing called a DHCP server. Dynamic Host Configuration Protocol is what it stands for. It sends the IP address and all the other addressing information that's required, and those are called dynamic addresses, and that's the default for Windows. That's 32 or 128 bits. We said that IPv4, the 32-bit, IPv6 uses the 128-bit. It says currently a shortage. Currently there are no new addresses. Now that doesn't mean that all the addresses are actually in use, because some of the universities that were on the front end of the internet have large blocks that they're not using. but they don't do us a whole lot of good. IPv6 128-bit. IANA is the organization that assigns these things. So we're getting to the how this actually looks to the computer. We have 1, 2, 3, 4, 5, 6, 7, 8, and it represents a 255 in decimal. You're shaking your head. We have placeholders, just like in base 10 we have placeholders. The first one is 0 through 9, right? You have any problem with that? The first one in here is a 0 or 1, so 0 through 9, it can represent 1. The next one is 2, and the cool thing about binary I have to be able to do is multiply by 2. 2, 4, 8, 16, 32, 64, 128. And when you add all of those together, you get 255. 255 different numbers. 0 to 255, but they're represented by binary numbers because that's what the computer reads. Huh? All we use are zeros and ones to represent placeholders here that have value. And when you add all those values up, you get 255. So we can have anything from 0 to 255, which is 256 numbers. Remember, techies count 0, 1, 2. You are a techie. Tech guys. 0 represents something. It's not the null set. It actually represents something. So we had all 255s. We have a whole string of 32 ones in binary. Each octet's 4 bits. We break them up into octets because there's 8 numbers in each one. 8 ones or zeros in each of the areas separated by dots. The highest number that can be in an IP address is 255. If you get something like 258 in it, it's not valid.
And actually, depending on where that 255 would be a broadcast fitting.
Maybe. Don't confuse them. Don't confuse them.
No, this stuff is already confusing.
Don't confuse them. Don't confuse them anymore. Yeah, there's some other stuff, but that's going to be Network Plus. You're going to have a lot of fun in Network Plus. In the network class. The octets, we break these things, and this shows A's, B's, and C's. These are the ones that you can actually use. There are actually 2 other classes, the D's and the E's, which we can't use. What they did is take these things and break them up. An approximate number of networks or licenses in a Class A, 126 networks, but you can have 16 million IP addresses, computers, whatever, anything that's got an IP address. 16 million on each Class A network. That's a lot. If you had a network with 16 million addresses, you Network Plus grads, would you be able to communicate? Not Windows, because there's too much broadcast traffic. Windows just sends stuff. Then we have Class Bs, and what this is representing in the Class A, we have the 4 octets. Will you agree with that? We have the 4 octets. The Class A, the network address is in the first octet, and everything else is a host address. And that's how we get to 126, because it goes from 0, which you can't use, 1 to 126. 127 is actually there, but 127 is a special thing called the Loopback Address. The Class B address, the first 2 are network, and the last 2 are hosts. And with it, you can have 16,000 networks and 65,000 hosts per network. The one that you'll probably have to know, this is the note, the Class C network, the first 3 are the network address, and the last one is the host. So we can have 2 million networks, but 254 usable addresses. because they used some terms over there a while ago. We have two addresses that you can't use. Their name, the network address, and the broadcast address.
Well, which one of these is better, Class A?
Neither is better. It depends on what you're trying to do.
What would Class A be used for?
IBM, state.
Well, what really happened is really big business. What really happened is that the people that were at the front end of the internet, MIT, for some reason University of Iowa, and I think probably Stanford, got Class A networks, which means that they have 16 million addresses for each one. So if you've got a couple of Class A networks, you've got a lot of addresses that you can use.
Yeah.
Class B networks, not so much. 16,000, but you still have 65,000 per. I'm going to say a word, and then you're going to immediately forget it for right now until you get into the networking class. It's called subnetting because this is an unwieldy number, 16,065,000. It's not going to work. So you have to break them down into smaller segments, and that's called subnetting. The Class C networks, 254, that's relatively large, but it's still a reasonable number of hosts to have on a network.
That's great. Trying to break down 65,000.
Well, try about trying to break down 16 million. We're going to make them smaller networks. And that means that we can then use them better because we're not going to be able to put 16 million on a network.
Just like if you were a big multi-chain.
Well, you do that, but what it's like is, how hard is it to spend a $100 bill? Not that hard at all. Some places won't take them. We won't take. That's what I'm talking about. I'm not talking about how hard it is to make it go away. How hard it is to get somebody to take it.
Yeah, especially after dark.
Especially after dark. What if you can break it up into smaller parts? 520s. That's what subnetting is. 101s. Smaller network. That's all subnetting is you're breaking it into smaller parts. It's like 520s for 100, 101s, or 1010s, whatever, however you want to break it up, with the number of addresses that you have. Classes are based on the number of possible address assignments in these things. Class A, the first octet, I think we've already said this, first octet and the last three can be used for the host. The first octet is network. Class B, the first two are network, the second two are host. Class C, the first three are network, and the last one is host. And you have the numbers there. This is we do have a Class D and a Class E. Class D is multicast. We can't use those. Those are special category. Class E addresses research. I've heard all sorts of things. Research, military, on and on and on and on. They're research. We can't use those either. So what we can use are the A's, the B's, and the C's. And this is an image that, based on the octets, the Class A, the first octet network, the last three hosts, each half and half in the B, and then more network than hosts in the Class C.
Classes, right?
You can what?
Hack into this stuff, right?
You don't have to. There's no hacking in. It's called subnetting. You don't hack into that. I think that
255, that's the biggest you can have it, right?
255 is the biggest thing because we got 8 ones. 255 is the largest number that's available in any single octet.
You got like the largest octet right there.
255, 255, 255. The 255s in this it's called a broadcast. And a broadcast goes to everybody.
Like a TV station?
You know, exactly, like a TV station or a radio station, except it broadcasts to all its computer friends instead of to whoever's tuned into that TV or radio station. A 127 is called a loopback address, and it is your own computer.
That's the halfway point?
It allows Windows to find itself, basically, or all the operating systems to find themselves. That's a loopback, and it's for troubleshooting. Specifically, what it is designed for. Subnets, and all I want to really say about subnets in this class, because you'll get more subnetting than you ever want in the network class, and Matt's giggling, and he's right. Yep. And you know what? My routing classes found out stuff never goes away. So I'll get through this class and it'll go away. And then you come to infrastructure, and I'll get through this class and it'll go away. Get to routing, and it becomes really important, and I'll get through this class and it'll never go away. But how you manage, that's how you manage networks. I'm sorry, what did you say?
I said then you get advanced routing and switching.
Then you get advanced routing and switching. And then you get the routing lab.
No, that's not the same way. I'm sure it's plural.
There's no class of lab. There's only 4 labs.
That is true.
There's only 4 labs.
That's it?
Oh, yeah.
Yeah, right.
No, there are only 4 labs.
Yeah,
What does it take to do the last one? Probably 8 or 10 hours?
Yeah, something like that.
these labs,
So there's only
that's
5
labs.
hours in the day.
Huh?
That's only 5.5 hours in the day.
If you think that you can go through this curriculum and learn anything by spending 5 hours here twice a week, then you're going to be sorely disappointed.
Yes, don't wait to do that one to the last night of class.
Some people have. They have a tendency to do that, yeah. Subnets break large networks into smaller networks. It's like we said, it's like 2 5s for a 10, 5 20s for 100, whatever else. The way you manage that will learn the technique in the networking class. The subnet mask is 2 sets of numbers. One's the IP address and the subnet mask. Subnet mask tells you how much is network and how much is host, and that's all that it does. The ones and zeros, the subnet mask, and these are the subnet masks for the class. The subnet mask for class A is 255.0.0.0. Every place there's a 1, first octet, every place there's a 1 says that's network address. This one, the first 2 octets are 1, says that's network address, just like we said in the classes. The reason that we're here when we start subnetting, we're going to change the subnet mask. The only thing we're going to do is move it to the right to make it more networks and fewer hosts per network. That's the way we're going to break it down into smaller components. Yep. We'll do that networking. What I want to try to get through here are the concepts that I think you need for this class, because there's a much more extensive. We spent 2 classes, 10 weeks doing networking, and in the second class you spend about 2.5 weeks subnetting.
Yeah.
So yeah, by the time you get there, you'll do that one. I don't want to even attempt to try to go through subnet, because it's not something you're going to learn in 2 hours or a night. It takes time. It does take a lot of practice, and you'll get a lot of practice. Public IP addresses are available to the internet. Public IP addresses. We have private IP addresses and public IP addresses. The thing that I think you'll need to know, and this is what I think you'll need to know for this one, the public IP addresses can be routed on the internet. The private IP addresses, and we're going to have the ranges here in a minute, are used inside of our network. Our network in here has private IP addresses. We use the 10 dot something. 10 is a private IP address. When we go to the public area, use a process called network address translation, where it translates or assigns for your private address a public address that can be routed, and then when the answer comes back, it sends it back to your particular machine. So NAT, and if you have cable modem or whatever at home, That's what you're using, because how many IP addresses do you buy? I buy one, and I've got 4 computers and 2 tablets. And they're all getting on the internet because of this NAT. We'll call it NAT, more properly PAT, port address translation. But what this allows us to do is to use a single IP address on the public end to support multiple computers on the private end. You could actually run a business with one public IP address. That's what's made IPv4, one of the things that's made IPv4 last for so long, is because we found other ways to extend the life of that protocol. The private IP addresses are here, the 10.0.0 through 10.255.255.255, so all of the 10 addresses are private Class A addresses. 172.16 through 172.31.255.255 are the private Class B addresses. 192.168 through 192.168.255, the whole 192.168 is a Class C private IP address. You can use those on any private network that you want. They're uncontrolled. You don't have to pay for them. Public addresses you have to buy. And that's why you want to use as few of them as possible. This is what an IPv6 address looks like. It's kind of, I think, kind of a pain because it's written in hexadecimal. It's not written in decimal. So it's got all these odd things like B's and whatever. The highest this one can go is to F. 15. F is 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Because I started with 0, there are 16 numbers, 0 through F.
But look, they don't mix the decimals with them.
They don't mix the decimals. Well, because hexadecimal has decimal numbers in it. It just keeps going further. It's base 16, not base 10, not base 2.
Base 2 is 0 or 1?
0, 1.
Yeah, it's binary.
Yep. Base 10 we use every day. Base 16, 0 through 15, 16 numbers. These are things that, again, I think a lot of this stuff more properly, link local, local link, and interface, those kinds of things, probably better covered in the Network Plus, although IPv6, again, it's imminent. We're going to use it. It's an imminently, we have to go to it. I don't know, I think for what I've been hearing is at least 6 years, maybe 10 years, that yes, eventually, immediately we're going to go to it. We're going to eventually go to it. And oh yeah, by the way, guys, it does have subnets too. Bigger subnets! 3 tunneling, and again, I don't know, you have to have these isotap, Teredo, and 6 to 4. What these are for as we transition from IPv4 to IPv6 allows you to use both protocols. And what it really does is intrasite automatic tunneling address protocol. What it does is if you're doing a 6 to 4, we'll put a 4 address on the 6 and send it across the 4 network. When it gets to the other end, takes the 4 address off and then uses the 6 address on the 6 network. Unicast, multicast, anycast addresses, nice terminology. Probably at this point in your schooling doesn't make a lot of sense. Well, the Network Plus grads may, but unicast goes to a single computer. Multicast goes to a group of computers. And anycast is used by routers to identify multiple destinations. Anycast is what we would used to call broadcast. Broadcasts are not available anymore in these things. This is the way that they're broken down, 64 bits. 64 bits for the network, 64 bits for the interface. Lots of addresses. And it depends on how the address is actually constructed on these things. There's lots of rules, and they have changed a little bit in the not too distant past. What addresses they're going to use and what addresses they're not going to use. IPv6 has to be used in some parts of the world. At one time, the continent of Africa had 2 Class C address ranges. So you had 512 addresses for a whole continent.
What?
The Far East, because they are so wired, IPv6 is used there. We invented the internet, we invented all this stuff, we got most of the addresses, so we really haven't been forced to transition to it yet, although that's going to happen at some point. To view your IP addresses, ipconfig is the command that you would use. ipconfig is going to show you the IP addresses, version 4 and version 6 for all of your interfaces, and there's some activities that you can look at these things when you do that. Command prompt ipconfig, and ipconfig has a number of switches that you may want to look at. Show DNS, display DNS actually is a command. Flush DNS. The display DNS shows you which ones are in cache. And flush is if you have stuff cached and people changing IP addresses, you need to flush it so that you can go get the new IP addresses. That happens occasionally, particularly in Active Directory. Fully qualified domain name. Domain name identifies the network. Fully qualified domain name is a www.yahoo.com. roa.skyline.edu, the fully qualified domain name. A fully qualified domain name for one of the computers in here might be rke-rm111-003.roanoke.ecpivab.edu. That's the fully qualified domain name. The computer name is rke-rm111-003. Host name, NetBIOS name. When you append the domain name, roanoke.ecpivab.edu, to it, then we get the fully qualified domain name that can be looked up in DNS. The protocol layers here are applications, and this is another one that the 7-layer, the OSI model, don't want to go into in any detail, except there is such a thing here. What this allows, it's a modular thing that as the technologies change, you can move stuff in and out. The different services operate at different levels of this. The 7-layer model is another thing that you're going to get a big dose of in the networking class. Big dose of in the networking class. So what operates down here at the basic level, we get the wires and the voltages, the NICs, and those sorts of things. Then we move on up to the network layer. We get our IP addressing and some other protocols that are going to associate MAC addresses and IP addresses. Transport layer, TCP, and then in the application and presentation layers, all those things that we've been talking about, HTTP, the web server, FTP, the file transfer, the mail stuff, SMTP, POP, and IMAP. And that's one that seems to be knowing what those are seems to be one of the focuses, particularly on wireless devices. And it makes sense because that's what do you use your wireless device for? Huh? Internet. Do you get your email on it? Internet email. GPS. Yeah, those are other functionality, but these are all web stuff. So the mail you have to know how to configure SMTP, POP, and IMAP.
I got a question. Do GPS take internet to use it?
I can't answer that question. I don't know because I haven't ever looked at it. GPS in my car, I don't need the internet because it communicates directly with the satellite. And I think that the phones do the same thing. The locational data communicates with the satellite. TCP, another term that you're going to get a lot of practice with, connection-oriented. What connection-oriented means is that it establishes a connection before it starts sending the information. It's like a phone call. If you call somebody, hello, they say hello, hello, this is, and you do the identification. This is called a three-way handshake to start up the connection, and then you start sending the data. It creates the connection, and then you send the data. There's also, and it says used by web browsers, email, a lot of other stuff. UDP, user datagram protocol, is called connectionless or best effort. It just kind of sends the stuff. And the implication is that you just send it out there and hope that it gets there. Well, what happens here, TCP, the transport layer, doesn't assure delivery, but the other layers checks to be sure that it got there. Applications, different ones, and again, I think that if you look in the objectives, and you can get the objectives on the in the students' apps drive, they have a list of applications of ports that they want you to know about, what ports associated with what application. It's not a real long list, but it's more than 3, but less than 40, I guess. I think it's probably less than 20. But those are there. POP and IMAP, delivery of email messages, SMTP, send, mail. So if you're going to configure mail, you can SMTP and POP3 or IMAP, either one, configured on your device, your phone, your tablet, your whatever. And this just goes through a list of things that you can read. There's no need in me talking about that, I don't think. Connecting it to a network, connecting the network using Ethernet or wireless or dial-up connections. Ethernet's really tough, you plug it in. Wireless, not so difficult. Got to know the password. Dial-up connections, they're still out there. We hope that you don't have one of those. And these are the steps that are in the book, and there's troubleshooting, verify the device manager, recognize it's all the other things. Did it get in? Did the driver get in? Is it up? Is it plugged in? That happens more times than you might think, that it's not plugged in one place or the other. Red X indicates a problem. Things that you've done before. When you look at the networking in Windows 7, it gives you a picture up here going through the router, and this one going to the internet. This one says it's okay. If you have a red X here, there's something wrong between here and the internet. DNS can be that issue. And it could just be that it just started up and it really hadn't tried to get to the internet yet. If you go there the first time, it says it's okay. It's just a little visual indication of what you can do there. Change the adapter settings, the step-by-step on how to do that. You will need to know how to do this, so practice this one before you get there. I know if you do the networking class, you've done that a dozen times, at least. Probably dozens of times. In this class, not so much, but know that procedure. What you do basically is right-click on the NIC, go into the TCP/IP properties, and go into the IP address. You can change the IP address and the gateway and all of the IP addressing information. Use the DNS server address. If you have IP addresses, DNS servers, check to be sure you enter them, because you have to put an IP address in for a DNS server. It can't find itself. That's one. It does have to be by IP address, not by name. Disable and enable. One of the things, and this only shows one NIC, one of the things that I found that Windows does to you sometimes is if you have two NICs and one of them's plugged up and one of them's not, it sometimes gets confused and tries to go out the one that's not plugged up, and then it doesn't do anything. So instead of leaving one out there with a red X saying it's unplugged, disable it. It won't try to use a disabled device. Wireless network. None of you ever use an unsecured public hotspot, right? just be careful. The message here is be careful. There are lots of people out there trying to intercept your traffic.
So,
If you do anything significant, it's probably going to be
you
security.
know, when, like, your house, your neighbor...
Your house is fine. The house of your neighbor, probably not an issue. I'm talking about McDonald's, Starbucks, country cooking, those kinds of things. Denny's. You guys have a wireless?
Yeah, we have free
Yeah.
Wi-Fi.
Free Wi-Fi. Free unsecured Wi-Fi, right?
Yes.
Unsecured, which means that anybody can get on it,
Yep.
which means that anybody can see your traffic. If anybody can get on it, anybody can see your traffic.
That's why you put it on public.
That doesn't do that. When you put your public, you're talking about when you make it a public network, what that does is configures the firewall so nobody can connect to you. But your outgoing traffic is still visible to everybody that's on that network.
You don't really have to worry about it so much at Denny's because there's a very high possibility you won't even be able to connect to the internet to have anybody view your...
That's neither here nor there, but... Okay, so go to Denny's and connect and don't use the internet.
Don't worry.
His Denny's.
It doesn't work half the time, so...
Connect to the wireless network. I do have an activity to use Packet Tracer to do some wireless router configuration. You've probably done it. It should be pretty straightforward to do those things. These machines in this room you can connect to a wireless because these machines have wireless NICs on them. Except for a couple of them that have been broken. Any of them that have the little boxes on top with the blue light have wireless.
So would that be like, the IT guy for this school, he put a wireless chip in my computer.
He did?
So
Okay.
would that be the same as that?
He put a wireless NIC in, right?
Mm-hmm.
Yeah. Well, that's what this is. That's what this is. It just has an external antenna.
Oh, okay.
Yeah. Using wireless are you created using access points. A security key is required, maybe as long as you have security enabled. SSID may or may not be broadcast. This is not broadcasted. The SSID normally is broadcast unless you turn it off. But as James found out in the wireless class, it's still there. You can find it if you really want to look at it. That's one of the things that people use to not make their wireless networks visible. And you can do that at home because typically people that are trying to use your wireless don't understand that they can really go find it anyhow. We also have computers with registered MAC addresses are allowed to connect as long as we enable what's called MAC filtering. And then you put the MAC address in. And only those computers are allowed to connect. The problem with that one is I just watch your network find a MAC address and put that MAC address into my machine. So I can still connect. Those are all protections that will help some. Cellular, we have the SIM card, and the SIM card actually is what makes the phone work, right? If without the SIM, it doesn't work.
Yeah,
Agree with that?
iPhones don't have a SIM card.
Yeah, they do. They have a SIM of some kind. Because that's the only way that you're going to be able to connect to the network,
Well,
to those networks.
when you say SIM card, I think about the card that you can take out.
Yeah,
It's like a white card.
yeah, that's the SIM card.
Yeah, a lot
Yeah.
of phones don't have it.
This is the battery. The SIM, they have something, it's maybe programmed in, but they have something that connects with the network.
Tethering. I know what tethering is.
Hmm?
I know what tethering is.
You know what tethering is, yeah.
You do it at my
Tether your cell phone to your computer, you use
phone.
your data package to connect your computer to the internet. Not real fast, is it?
No, not at all. And you can do it through Bluetooth. Like
And you can do it through Bluetooth, yeah. as rudimentary as my phone is, it doesn't tether like that. It uses Bluetooth. And I think most of the new ones do use
I don't think I
Bluetooth.
can tether on mine.
Some you can, some you can't. Depends on the provider.
Like, I don't think straight talk will all of it.
Tethering the Bluetooth. Like,
Yeah, you've probably got Sprint.
Yeah, I got Sprint. You can do it through Verizon and all that.
You can buy AT&T not unless you get a
you gotta
special.
buy it.
You got to buy it from AT&T. Yeah, so it depends on the provider. It's technically possible, but maybe not allowed by the provider. So we can use a cell phone, dial up, bare bones installation, and there's a procedure in the book. I don't get real excited about the dial-up connections because most people don't use them. The one time that you might use this is if you're using your computer as a fax machine, because you have to have a dial-up, you have to have an analog line for fax to work.
Wow.
Because that's the way fax works.
Why don't they change it to digital?
Because it works really well with the analog. I don't know. I can't answer that question. You have to ask a designer. I'm not one of those guys. And the process to create a dial-up connection, again, is one of the ones in the book. One of the other activities that having you do is create a VPN, a virtual private network, an encrypted connection. It's not a complex task. If you want to encrypt stuff, you encrypt it from one computer to another, you're going to use a VPN. I want to go back to this open wireless network, which I said everybody can see your traffic. If you're using HTTP, if you're using HTTPS, it's going to be encrypted. If you go to your bank or anything that actually email, any of that stuff, it's going to be an HTTPS. So you're going to have an encrypted, essentially a VPN between your computer and that server. ESPN is not secure, but who cares? Who cares what you're doing there? You're not putting your credit card number in or anything like that, right?
You can buy stuff on ESPN. I'm just saying.
But when you go there, you'll go to an encrypted.
Can you just type it in
HTTPS, as long as the web server has a secure service running. Remember those ports? HTTP is 80, HTTPS is 443. If it's not got 443 service running, then no, you're not going to connect. You got to go with what's there. It's kind of like going to a restaurant. If you go to McDonald's, you're not going to get a Big Mac. Or you're going to get a Big Mac. You're not going to get a Whopper, are you?
I mean, I would get a big chicken personally, but
That doesn't matter. But if you go to Burger King, you're not going to get a McChicken. If you go to Arby's, you're not going to get a Big Mac. So you only can connect to the services that are running at that place. If you want an ATM, you got to go someplace to get an ATM, right? If you want to get money out of the ATM, you're not going to get it in this building because there's not an ATM.
Some colleges do have ATMs.
Some do. VPN connections create a tunnel. Encrypted connection is a better way to think about that. The steps are in the book to do this, and that's one of your activities for tonight. A multifunction router, this is the other one of your activities for tonight. There is a file that you can use, will use to do that, and it'll tell you what your grade is as you go. As you do things, it'll go up. You should be able to get 100 on it. And it's got a place to upload it. Soho small office, home office router, which is the things that you and I probably have. The routers, the wireless access points that we have are those. And they use NAT, actually, Pat, to be more specific, because we only have one address. A NAT is a one-to-one private IP to public IP translation. Port address translation, we use one public address and we translate all of our private addresses. Because we have 65,536 ports, we can do that, to use those. Install and configure. The password for the router that you're going to use on the lab is, the username's admin, the password's admin, so it's admin to log in initially. And all of these things, that's the problem with the leaving these routers set as the default, because what's the username and password? It's admin blank, or admin password for the big three. So you can own somebody's network pretty quickly. Port filtering, this is what you were talking about when you said it's a, when we mark it as a public address or a public network, when we go on these places. Port filtering says don't let them in. If there's something running on your machine, either do or don't allow. We can either deny or permit the ports to go through the firewall. Port forwarding is something you would use at home. All you guys who use torrents, you have to do a port forwarder. You should do a port forward, right? You do a port forward. You go to the router and you forward a particular port to a private IP address in your network. What that says is if you connect from outside your network, allow it to go through and send this traffic to that computer. Port triggering opens a port when a PC on the network initiates communication through another port to allow to those things. We have a DMZ. A DMZ is an area that everybody can get to limited number of things. Demilitarized zone. DMZ. What you usually put in a DMZ is a web server. Maybe an FTP server. So, because if you're selling stuff, you want everybody to be able to get there, right? To buy your stuff. So you put that in the DMZ. You don't necessarily want them to be able to get to all of the resources. That's going to be our protected network, our internal network, which you have to get through a firewall to get to it. Install and configure the router. You can look at the port forwarding, those kinds of things, and I think I actually have you do one port forward in it. The wireless networks, the A, B, G, N, and now AC. The AC stuff's coming down pretty good. I saw an AC, and it's not as cheap as the N's and the B's and the G's, but I saw one this weekend. I think it was $149 for an AC, 802.11 AC. It's the new standard. 802.11a, 54 megabits per second. 802.11b, 11 megabits per second. 802.11g, 54 megabits per second. 11N, 500 megabits per second. 802.11ac, a gigabit per second.
What? Pretty good transfer.
That's pretty good transfer. A gigabit per second.
Yeah, I know that. I just couldn't believe it.
Yeah. Gigabit, wireless gigabit, 802.11ac.
Give me some of that.
$149 Best Buy. Yeah, for the router. Now you got to buy a NIC.
No.
You have to buy the whole thing, right? The latest standard. The others are what's called draft. It's in the draft phase. They haven't been approved. What they're selling is probably what's going to be approved. But 802.11n is the latest one that actually has been approved. Most wireless devices, 11, B, G, and N. What you really don't want to do is mix these things, because if you, for instance, get an 802.11b, 11 megabits per second, system connected to your network, you just made your network an 802.11b network. So you don't want to be in mixed mode. You want to say either B, you want to say either G or N, so that you make people move up. There's no real reason to be running B anymore. I'm not sure there is any B out there. I probably have some because I got a bunch of old stuff. The frequency ranges, the older networks, say 2.4 gigahertz, been around for a long time. What makes N so much better is it uses both the 5 gigahertz and the 2.4 gigahertz. 5 gigahertz was originally the 802.11a. 2.4 gigahertz was originally 802.11b and G. It uses both of them. It uses multiple antennas so they can send more than one thing at a time. The network will use a channel width 40 or 20 megahertz. When we do 802.11g, we actually only have 3 real channels. Right? 1, 6, and 11 are the only clear channels that are available there. 3 main protocols for encryption. WEP, if that's all you got, it's better than nothing, but not much. Easily hacked. Plenty of videos at YouTube how to do it. You can hack it in maybe 5 minutes.
Hold on, what did you say?
WEP.
Go back.
WEP. Huh? WPA, better than WEP. WPA2 is the one that you really want.
How do you get into that?
This is, you're going to do that when you do the configuration. This is on the security of your wireless router. This is on the router. This is on the router configuration, not the computer configuration.
How do you get into somebody's
WPA2?
That's what I thought we were talking about.
No. I just said that WEP is easily. It's better than nothing, but not much. WPA, Wi-Fi Protected Access, WPA2 is actually AES, which is a pretty good encryption standard. You've got personal and enterprise. WPA personal, WPA enterprise, WPA2 personal, WPA2 enterprise. If you use an enterprise, you have to have a radius server in order to do the authentication. Security and wireless, disable the SSID, MAC filtering, Wi-Fi protected, WPA2 security is the one that you want on these things. This has really been an overview. I know that I did a cursory look at a lot of the IP addressing stuff because you're going to get it in a lot more depth. And there's no need in confusing everybody and taking a lot of time for something that you really are going to get in a lot of depth. Take this as it's coming, and when I get there, I really need to pay attention because it never goes away. The two that are in here that have had it, just finishing it. You guys are good at subnetting now, aren't you?
Yeah. I love subnet.
Supernetting is, what's so hard about supernetting?
No, it's just you have to think about it for a minute.
You just go the other direction.
The process.
You just go the other direction. You're making them bigger instead of littler. So the router, are there questions about what we did do here?
You got 24 files.
Change for a 5. You want a subnet, huh?